Right, matriculants, as you know, this week we're going to be revising a question in your paper 2. So, this question, as you can see, it has a lot of analytics inside it, so you need to know all your analytical geometry, as well as you can see this big beautiful circle over here, circle analytics. So, a question like this should come for about 20 marks in your paper 2, so this should not take us more than 25 minutes. So hopefully we can finish around the 20-minute mark, then we will be good in the neighborhood. Lovely. So with regards to this is the revision that we've done on circle analytical geometry in term number 1. Lovely. Hopefully see you guys next week, as tuition will be opening up next week. Remember, for those students who feel that they do not want to come for tuition due to coronavirus or etc., the videos will still be posted online for you guys. Lovely. So, the first thing that we're going to do over here is we're going to go ahead and talk about the specific circle. So, as you can see, here's the circle. You can see that the point of M is now the center of the circle. Lovely. You can see that that's the point of R and P. Lovely. So now that you have all of this here, you now can talk about specific things in the circle. As you can see, point of R is on the circumference on the circle, and there's the line or tangent there. Then you can see P and M are also a tangent, and it also touches the circle at one point, so it's a tangent to the circle. You can see M is also on the circumference of the circle. We see that they gave us the circle at the point of R is 0 and minus 4, lovely, and then we have the equation of the circle. So see, this is what you need to go ahead and do before you see or you answer the question. See what you are given. Before you read all of these here, you can say, okay, this is what I'm given, this is all the things I had, all of the what's missing, what's not missing. So if you can see here, M is missing, P is missing, even N is missing, they might ask us to work out all of those specific type of things. Lovely. So, let's talk about mainly looking at the first question. It says show that M is there. Now, M is the center of your circle. So, how do you always derive the center coordinates? You have to take it from your equation. Now, if we're given our equation over here, so we're looking at 6.1. The first thing that we need to do with this specific equation is what? We need to complete the square. But we need to complete the square of the x, and we need to complete the square of the y. And after we complete the squares, we will have our center as we take it out of the equation and change the signs around. That's how we will be able to show you that m is 3n minus 1. Understand? So let's go ahead and look at this here. Let's first arrange it in such a way, x squared minus 6x, then you see I put the x's together, then we can say plus y squared plus 2y, right? And then minus 8, what can we do to it? Take it over so it becomes 8 positive 8. Lovely. So now we've done that there, we've arranged it in the order that we would like to work with it in. Now what do we do whenever there's completing of the square? We go ahead and we say we put a plus on the side and we say equals to 8 plus on that side. Right, we're going to half this one and then square it. So if you half 6 and you square it, it becomes 9. Can you see? So what must we do there? Plus 9. Then we're going to say plus y squared plus 2y. We're going to half 2 and square it, which will just give us plus 1. So we're going to have another plus 1 there. Lovely. So that's 10, that becomes 18. Right, then here, now we're going to complete the square. Remember, you're going to open up two brackets exactly like this here and work with them. So, x, take the sign of the center one. So you see, how do you complete the square? You take the root of what? The first one. Understand that, 100% sure. You do what? You take the root of the first one, the sign of the second, and then the root of the last one, which is 3. Then you go ahead and do the same thing. You put a plus, you say the root of the first one, the sign of the second one, and then what's that there, youngsters? the root of the last one, and the root of 1 is 1. Then remember, you have to square that side and square that side. So, now if you want to show the center, remember, m's coordinates, now all you do is you change the sign of x and you change the sign of 1. When you take it out, so it becomes 3 and minus 1. Can you see? You've now shown that m is equals to that there. So you can go ahead here on your coordinates, you can say that's going to be positive 3 and minus 1. Lovely. So let's just recap what we've discussed then. The main thing that we're going to discuss is how we showed that our center M is there. We have to do what, youngsters? We have to do completing of the square. So how do you complete of the square? We complete for the x, we complete for the y. Remember to take your numbers over, and then you have it in terms of your radius as well. Remember, this here is your radius square. It's your radius squared. So if you want to actually calculate your radius, you have to do what? You have to root that 18. Lovely. So that was 6.1. Let's have a look-see at 6.2. So with regards to 6.2, M on the equation in the form of y is equals to mx plus c. Now I didn't write this question out full, but what it's trying to say is calculate the equation of mr. So mr in the form y is equals to mx plus c. So there's two steps that you need to apply. You need to apply your gradient step, step number 1, and step number 2, or y2 minus y1 all over x2 minus x1. Then in step number 2, what are you going to do, youngsters? You're going to apply the form y minus y1 is equals to m into x minus x1. If some children learn y is equals to mx plus c, same form, same thing, gets you to the same answer. Now you're going to say, okay, they wanted m and r, so we need to use this, we need two sets of coordinates. So what are my two sets of coordinates that I'm going to use? I'm going to use m's coordinates, because we've shown m is plus 3 and minus 1. And then I'm going to use what coordinates? R's coordinates, and r's coordinates is 0 and minus 4. Lovely. So now that I know I'm using those two specific coordinates, I go ahead and I apply my gradient formula. I can call this y2, this will be x2. I can call this y1, that will be x1. So I go ahead and I say y2, which is minus 1, plus y1. Remember, the negative here and that negative will now make a positive, plus 4, all over a positive 3 minus 0. Can you see it was minus 4 and 0. Lovely. So let's go ahead. That gives us positive 3 and that gives us positive 3. Your gradient is positive 1. Lovely. Can you see how quick, easy, simple that was? Nothing difficult. Remember, this gradient formula comes from where, youngsters? From your analytical geometry. Perfect. Right. So the next thing that we're going to talk about with regards to this here is this y minus. What was our y1 equal to? So let's make it plus 4 is equals to m. Now remember, in place of m, what do you write? We do not write m anymore, we write 1. Then we're going to say x minus, and minus x to 1 is 0. So it's going to be 1x, and then take it over, y is going to be minus 4. So therefore, MR's equation will be there. Can you see that? Quite simple, quite easy to understand. Not anything difficult, but youngsters, remember you have to take your two sets of coordinates, do your gradient formula, and then your straight line equation, and after you do that, there you are, thumbs up and ready to go. Lovely. Okay, so I'm going to raise this to now, and then carry on with the 6.3. Right, so with regards to 6.3, it says that show that Q is equals to 2 minus P. Show that what? Q is equals to 2 minus P. So, how are you going to show this Q equals to 2 minus P? It's quite simple, youngsters. The main thing that you have to think about here is gradient, right? So you needed first step 1, so let's do here 6.3. The first step that you needed here, step 1, was your gradient of mn. mn, right? So what do you think your gradient of mn was going to be? Remember, we worked out the gradient of mr to be what? Positive 1. Now remember, this is a 90 degrees here at the center. So if I wanted my gradient of mn, it was going to be minus 1. Why is it going to be minus 1? You can show a bit of a side calculation over here, cause mr multiplied by mn must have given you minus 1. Remember, that's perpendicular 90 degrees. So that's what that specifically states for. Then you could have solved, you could have put 1 in there multiplied by mn, gradient, mn minus 1, then you would have had mn to be minus 1. That's how I've solved it. So now I know that's minus 1. Then I know my gradient formula is y2 minus y1 all over x2 minus x1. So now what coordinates do I specifically pick to put in place of that specific question? So what do you think that your coordinates that you're going to be to actually put it in? You're going to take n's coordinates, obviously. So you can take n, which is p and q. And then you're going to go ahead and take m, which is plus 3 and minus 1. Right, can you see those coordinates is what you're going to mostly use in this specific case to actually get your answers right. So you're going to say, now let's go ahead and say it's q minus, so plus 1 all over p minus 3 will equal to minus 1. Now remember, that's over 1, right? So you're going to say q plus 1 will just be here. Then this will become minus p plus 3. Can you see that there? Everybody okay with this here? Quite simple, quite easy. Now what are you going to do here? You're going to take that 1 over. So it becomes q is equals to negative p plus 3 minus 1. So q now equals to negative p plus 2. Now obviously you can just go ahead and rearrange it to look like this here. So you can go ahead and say it will be 2 minus p. See, I've just rearranged it to get my specific q. So if you're looking at this question here, a question like this will bring for 4 marks, a question like this for 3 marks, a question like this maybe 4 marks as well. Right, so if you're looking at this, you already scored most of your marks with the first 3 questions. So please, youngsters, don't give up on a question like this. Use your gradient. It is quite simple. You just need to think of it and you'll get the answer right. Love it. Okay, it says now calculate the values of p and q. How do you think that's going to work? It's quite easy, quite simple. So I'm going to erase this here. Remember, just have a look at it quickly. We have to use our gradient formula, sum in, and then just solve for q. Quite simple and easy. Now, they want us, remember, the reason I'm leaving this specific thing here. How can you write q? You can write q in terms of 2 minus p. Right. Remember, when we calculated our specific what, youngsters? When we calculated our specific equation, we can change this equation to be x minus 3 squared plus y plus 1 squared is equals to 18. Right. Now remember, this p and q are what, youngsters? Are your x values. So you take your equation, right? So I'm going to take that out. So you take your equation, you write it out. So now we're answering 6.4. Right. 6.4, we're going to go ahead and talk about this now. It's x minus 3 squared plus y plus 1 squared is equals to 18. Love it. Now I want you to calculate p and q. Watch how simple this is. In place of x, you're going to sub in what? P, obviously. So you're going to say p minus 3 squared plus y. In place of y, you can say q plus 1 squared is equals to 18. Right. Now, what's the trick to using the previous questions, youngsters? What's the trick to it? Watch and learn. In place of p, you're going to leave p minus 3 squared plus In place of q, you're going to write this here. 2 minus p plus 1 squared is equals to 18. Now to agree, you can go ahead and solve for p. Quite simple, quite easy. Let's see, this is squaring of a binomial. So you're going to say p squared minus 3 times 2 is 6 minus 6p plus 9 plus, let's see here, 2 plus 1 is 3. Fine. So 2 plus 1 is 3, right? So it's 3 minus p. So it's going to be plus 9, right? So what we youngsters? Plus 9. First time, second times 2, so it's going to be minus 6p. And then you're going to square p, so it's going to be p squared plus p squared. Right. And then it's going to be equals to 18, so bring it over, minus 18 is equals to 0. So plus 9 and that 18 will cancel now. Right, now you need to solve for what, youngsters? For p. So you have p squared minus 12p is equal to 0. We can take our p as a common. And left with p minus 12 is equals to 0. Right, take it over, p is equals to 0, p is equals to positive 12. So we know that p's coordinates will be positive 12, and we're trying to get q. What do you guys go ahead and do? You take it, you sum it back into any one of the equation, and you'll get q. So do you all understand how to get p, which is 12, and q, which I did not solve fully for? Now, right, let's go ahead and solve for that specific q value, right, youngsters? So we still need to solve for q because it's going to be used in the next question. Lovely. Right, youngsters, so now we're going to go ahead and we're going to take our p and solve for this specific q. So remember, in place of it, you can say q is equals to what? 2 minus 12, which will give you q to be minus 10. Quite simple, quite easy. See how easy was it. Now, why didn't we use the 0? Because we did not use the 0 because we can see it's not lying on our what, youngsters? On our circumference. So therefore, we did not use the 0, we used 10. So we can see that there will be minus 10. Now it says, calculate the equation of the circle having the center O. So if your center is your origin, you must already know that it will just be x squared plus y squared, because that's already if your center has the origin. See what they basically trying to say in this specific question is that you now have a circle passing through here. It goes like this, right around, as you can see, and that there is now your new center. So if you now go ahead and do what? Youngsters, you go ahead to say x squared plus y squared, y, it says it has the center O is your origin. So remember, your center will be 0 and 0. If your center is 0, you just put x squared plus y squared. Then you need to go ahead and calculate your radius. So your radius is basically from 0 to this specific point M, right? So if you go ahead here, you go ahead, that specific point is your radius. So how do you calculate it? You can use your distance formula. So you're going to say it's your x2 minus your x1 squared plus your y2 minus your y1 squared. So what does this give us, youngsters? It's going to be x2, so let's say we use the x there, 12 minus 0 squared plus minus 10 minus 0 squared. Now if we go ahead and do this here, 12 squared is 144. Right, and if you say plus 100 here, so it gives you 244, and whatever the root of 244 is, you basically go and put it there because it will be your radius 244. Right, quite simple, quite easy, not something so difficult, not something you can't understand. Right, so I'm going to raise this 2 out here, and then we're going to get on to that last specific question for this week. Right, so as you can see, it says calculate the area of the circle M. So if we're calculating the area of our circle here M, basically your area formula in 6.6, what is my area formula? So area is equals to pi r squared. So we know that pi will be something r was 18 and we need to root it. So it was just pi 18. Pi multiplied by 18, and then you can go ahead, plug this in your calculator and get your final answer. I can do my calculator here. Quite simple, quite easy, not a difficult question. As you can see, we are already 20 minutes into the question. So that should give you kind of a gist on how you should be getting it in your paper. Lovely guys, enjoy the rest of the week. Stay healthy and safe.